my channel, and today I'm going to be talking about geometry. Ever since humans have evolved from apes, we've been trying to understand our planet Earth in a better way. Originally, we started from counting objects to identifying patterns in nature. Then, we looked at more significant pieces of mathematics, like classifying objects, which is geometry. Like, for example, we have cubes and spheres. Furthermore, we developed more fields of mathematics as time progressed, and these were revolutionary, such as algebra, calculus, and differential equations. It is important to realize that the person who is regarded as the father of geometry is Euclid. Euclid created a book called Euclid's Elements, which revolutionized the field forever. In this video, I'm going to be talking about the basics of geometry, so let's begin. So geometry just starts with pretty much a line, a point, a line segment, a ray, and a plane. Okay, so this is a line over here. Now, as you see, the line has two arrows. The arrows just say that this line extends infinitely in both directions. So till infinity, till infinity. Over here, we have a point. If you think of a point like a dot in space, for example, we have a two-dimensional space or three-dimensional space, it's just one single dot in the whole space. So the point is essentially the basis for everything. For example, it is important to realize that we can have infinitely many points on a line. A line segment is essentially just a line, but it doesn't extend forever. So we have two endpoints. So these are called endpoints. Lastly, we have a ray. So we'll just write the names down. Point, line, segment. And right now we have a ray. A ray extends indefinitely in one direction, but has an endpoint in another. A plane, last but not least, is where two-dimensional figures are on. A plane extends forever. So there is essentially just no boundary for these sides. So it extends forever. So that's essentially just a plane. So we can write it over here. So if we just take this as a plane, but it extends forever in all directions, we can say that this is a plane. Okay, these are essentially just all the basic definitions you need to know in geometry until you move on to all the shapes and Euclidean things. Okay, so we have a line which extends indefinitely in both directions. We have a point which is just essentially a dot in space. We have a line segment which has two endpoints and doesn't extend indefinitely, but has essentially just a line in between it that doesn't extend indefinitely. We have a ray, which is an endpoint and extends indefinitely in only one direction. And then we have essentially a plane, where a plane extends indefinitely in all these directions over here. And we have squares and two-dimensional objects on a plane. It is also important to realize that we're going to cover the notation in another video, because right now we're just looking at the definitions, and plus it's also relevant to notice that we have a definition called collinear points. Collinear points are essentially when we have points on the same line. So say we have 3 points. These 3 points are on the same line, so we call P, Q, and R. Points P, Q, and R on the same line, so therefore they're collinear points. We also have something called concurrent lines, which I'll write over here. Concurrent lines are essentially when multiple lines intersect at the same point. So a line extends indefinitely in both directions. Point is a dot in space. A line segment has two endpoints. A ray extends indefinitely in one direction. Collinear points lie on the same line. A plane extends indefinitely in all of these directions, and concurrent lines essentially intersect at one specific point. Okay, so these are essentially the basic definitions that one must know for geometry. Now let's talk about parallel lines and perpendicular lines. Parallel lines are essentially when we have two lines that never intersect. Perpendicular lines, on the other hand, are when we have two lines that do intersect but at 90-degree angles. As you can see, we can form a perfect square over here, 90 degrees. Okay, parallel and perpendicular lines are very important because this over here is perpendicular, this is parallel. Perpendicular and parallel lines are very important because they possess some of the most important properties in geometry. As we'll see a little bit later, parallel lines are very useful when dealing with this problem over here. Perpendicular lines we're not going to be talking about a lot today, but they do have some relevant properties, like because they intersect at 90-degree angles. Okay, now let's actually talk about angles. An angle is essentially just when we have two rays connected to a single endpoint over here. As you can see, we have a single endpoint over here, and we have an angle. An angle forms like this. Now we can call this angle, let's just say 30 degrees. We can measure angles in degrees and or radians, but right now in geometry we're going to just be using, for example, degrees. Okay, so we have 30 degree angle over here. Degrees just measure how big the angle is. So this angle is acute because it's smaller than 90 degrees. Right angle is equal to 90 degrees. So, and this is acute. Right is like this. Obtuse angle is greater than 90 degrees. So we have, or say like this. Let's just call this 135 degrees. This is not accurate, but it's bigger than 90 degrees. Okay, so these are the type of angles: acute angles, right angles, and obtuse angles. Acute angles are less than 90 degrees, right angles are equal to 90 degrees, and obtuse angles are greater than 90 degrees. Okay. Now let's talk about two types of special angles. These are called supplementary angles and complementary angles. Okay, so we have supplementary angles and complementary angles over here. Okay, so what are supplementary angles? Well, supplementary angles are when we have two angles that add up to 180 degrees. So we have to realize what a straight angle is. A straight angle is just when we have 180 degrees like this. It's just a horizontal line over here. So supplementary angles, let's say we have a ray over here, and let's call this 30 degrees. So if we want to try to find the supplement of 30 degrees, we want to say what number, when added to 30 degrees, gives us 180 degrees. Well, that's just simply 150 degrees. So the supplement of 30 degrees is 150 degrees. Now what about complementary angles? Well, complementary angles deal with 90-degree angles. So say we have something like this, and one of the angles is 45 degrees. Well, what, when added to 45 degrees, gives us 90 degrees? Well, it's 45 degrees, because 45 plus 45 is equal to 90. Okay, so the complement of 45 degrees is 45 degrees. Okay, so the supplement of 30 degrees is 150 degrees. The complement of 45 degrees is 45 degrees. Notice that supplementary angles infer that we're dealing with 180 degrees. Complementary angles infer that we're dealing with the 90 degrees. 90 degrees and 180 degrees and 360 degrees are very important in geometry because 180 degrees is a line, 90 degrees is a right angle, 360 degrees is a full circle. Okay, so these are very important to realize because supplementary and complementary angles are important when we analyze some of the important problems. So here are some problems over here for supplementary and complementary angles. So let's just say that we have a line. Call this 26 degrees. Note that this is not to scale, and let's just call this we erase this. Okay, so we've got 26 degrees over here and 46 degrees over here. Now we want to find the supplement. So what is the supplement of 26 degrees? The question here is what is the complement of 46 degrees. Okay, now as we can see over here, the supplement of 26 degrees is essentially just 180 minus 26 degrees. We've got 154 degrees. So the supplement of 26 degrees is 154 degrees. What is the complement of 46 degrees? Well, now you may think, well, what are these two angles for? Do they have anything relevant with the complement of 46 degrees? Well, these two angles over here are just to trick the person trying to solve the problem. The reason is because these two angles add up to 46 degrees. We know what they add up to, so we really want to find the complement of 46 degrees. If it's 46 degrees, we don't care about these angles because we just care about 46 degrees. So this diagram is trying to confuse us. We can just treat this algebraically. So 180, well 90 over here, because it's complement and it's a 90-degree angle. So remember, this is the complement of 46 degrees. So 90 minus 46 degrees is 44 degrees. Okay, now that we've done two of these problems over here on complementary and supplementary angles, let's now talk about vertical angles. And let's just review before that. The supplement of an angle is just 180 minus that angle, and we get the supplement of that angle. The complement of an angle is 90 minus that angle, which is going to be the complement of the angle. Notice the complement is 90 degrees, whereas the supplement is 180 degrees. It is important to realize this because the supplement and complement are very different entities. Now that we've talked about that, let's look at vertical angles. So imagine that we have two lines over here. Now, as you can see, this angle, which we'll call A, this is not in our notation for an angle, but right now we'll call A, B, C, D. We can say that C is equal to D, angle C is equal to angle D. We can say that angle A is equal to angle B. How is this true? Because these are vertical angles. Now, we're not going to rigorously prove them mathematically, but as you can see, you can regard this as a fact or a theorem. Notice, so for vertical angles, in this case, for vertical angles, the diagonal for example, for A, we have no diagonal. Diagonal or vertical line or vertical angle below. Or in other words, for vertical angles, the diagonal or angle below it, the diagonal angle or angle below it is the same. Now you may be wondering, why diagonal angle? For example, over here we have it's below it. B is below A. That's why hence we have vertical, because it's essentially just a straight line. But where does the diagonal come in? Well, this is not the only example of vertical angles, because then we would be weakened by this fact, because we could only use it for limited examples, even though we can also use it for limited examples in the other, which I'm going to show right now. It still just expands the amount of examples we can use. For example, let's just say that we have a line like this. Now let's just say we intersect the line over here, and we state that this angle is 135 degrees. Let's find this angle. How do we find this angle? Because we know that we can essentially just, if we reduce the bottom half, we can essentially find this using supplementary angles. But how do we solve this right now? Well, the key comes from vertical angles. So the diagonal angle over here, the diagonal from 135 is this angle. The diagonal angles are the same. So this is also equal to 135 degrees, which means that these two angles are equal to each other. So the supplement of 135 degrees is, let's just call this, for example, angle Q. So the supplement of 135 degrees is equal to angle Q. Okay, what's the supplement of 135 degrees? Well, the supplement of 135 degrees is essentially just 45 degrees. So 45 degrees and 45 degrees. Therefore, Q is equal to 45 degrees. Okay, now that we've essentially covered what vertical angles are, now let's actually solve the problem over here. It is important to realize that we have to rather understand these more intuitively than rather just memorize them. Because if we just memorized, essentially, what vertical angles are, we might just have limited examples. Rather, if we understand it, we can actually apply it to more complicated problems in geometry. Okay, so we have this vertical angle over here, and we have to essentially try to find angle Q. This is pretty simple regarding the knowledge which we already learned. Well, if this is 26 degrees, well, what can we do? Well, if we're trying to find angle Q, we can just find the supplement of this. Well, 180 degrees minus 26 degrees is 154 degrees. We got 154 degrees, which means that Q is equal to 154 degrees. Let's have a slight variation on this problem. If we have a slight variation, then we essentially just have a line going like this, trying to find 123 degrees, and we're trying to find this angle over here. Well, this is pretty straightforward. Using our knowledge of vertical angles, we can see this is vertical in a sense, or if you have it more like this, it's diagonal. Right now this is vertical. As you can see over here, it's diagonal. So sometimes it's vertical and diagonal, but if you just shift the diagram a little bit, you can see it's diagonal or vertical. Okay, so right now, this is going to equal 123 degrees. Note, using our knowledge that we have vertical angles. So this, if we call this Q, Q is equal to 123 degrees. Okay, now that we've essentially just found what Q for this example is and the Q for this example is, let's look at parallel lines and transversal lines and a little bit more deeper example because we didn't cover them. Parallel lines. Well, parallel lines are pretty straightforward. Let's just say we have a line intersecting them, like this. Now, let's just say we want to find this angle. And given this angle is 32 degrees, find this angle, which we'll call P. How do we find this angle? Now, if we think critically, because in geometry, critical thinking is very important, let's just cover this part up. And essentially, in geometry, when you're dealing with angles, the most advisable thing to do if you don't know how to solve a problem is to essentially use all of your knowledge and try to just identify most of the angles. Let's just cover up this line over here, for instance. If we erase this line and imagine that we are only dealing with this line, then let's find the supplement of 32 degrees. Well, 180 degrees minus 32 degrees is 148 degrees. Okay, since we have 148 degrees, then we can realize that this is 148 degrees. Now, let's extend the line again and try to find this angle, P. Now, let's use our knowledge of vertical angles. So if we've got this 30 degrees, this is 148 degrees, then we can realize that this is 148 degrees. This is just going to be 32 degrees. 180 degrees. 180 degrees is this line, marking it. And as you can see, we're just going to have pretty much, we identified all the angles over here. Now we have to identify all the angles over here. Well, now we essentially, instead of mathematically rigorously proving this, we can just have to understand one thing. This angle over here is equal to this angle. This angle over here is equal to this angle, and this angle over here is equal to this angle, and this angle over here is equal to that angle. Which means that all the angles just match. So the intersection on this line is the same as the intersection on this line. Identifying that, we can realize that this is 32 degrees. And which means this is 148 degrees. Which means that P is equal to 148 degrees. Just to make sure we can mark it, this is 148 degrees, and this is 32 degrees. Now that we've marked all our angles, we can easily identify what P is, and P is 148 degrees. Now that we've essentially gained a better understanding of transversal lines and parallel lines, and this line specifically that intersects two parallel lines is called a transversal line. Now that we've understand or understood this, let's actually solve a problem over here. Okay, so we have to solve this problem involving a transversal line. It should be pretty simple. So let's draw two lines. And let's draw a line crossing them. We could extend the line. Okay. Now, let's essentially just try to solve this problem. Remember that we at most need one angle to identify pretty much all the angles over here that the line intersects. As we see, we got the one angle is 30 degrees. Before we do any other steps of the problem, let's just identify all the other angles. Because then if we just identify what we're trying to find, then we can just easily just jot it down. So let's find the other angles. Other angles. So that's what we're doing right now. So, obviously the supplement of 30 degrees is 150 degrees. Which means this is 150 degrees. And this is 30 degrees. Which also means that this is going to be 30 degrees. This is going to be 150 degrees. This is going to be 30 degrees. And this is going to be 150 degrees. Okay. Now that we've identified this, let's essentially just find what P, Q, and R are, because that's the problem. Well, Q is this angle. Q is 150 degrees. Notice that P or R is going to be the same as Q. R is going to be this angle. Well, that's just going to be 30 degrees. We can easily infer that P is going to be 150 degrees. But if we check, P is going to be this over here, which is 150 degrees. Q, this is Q, this is P, and this is R. Now that we've essentially gained a better understanding of the basics of geometry, we can make this video to an end. If you like this video and if you like this channel, please subscribe to learn more. Thank you.